Hey, how are you guys doing? I just came back home from office and this was a hectic day. Actually, past few weeks have been hectic since I've moved here. Uh, Days are going like this, but I have found a way to keep myself sane, and that's what the YouTube channel is all about. So I'll be continuing back from where we left the last day. We did I think insertion sort. So today we're going to do merge sort, and it will definitely refresh my memory. So, yep, see you there. Hey, welcome back. So, today we'll do merge sort. And merge sort, as you know, it's a very good example of a divide and conquer algorithm. You take a big problem set, you divide it into smaller and smaller pieces, and then you start solving it. So, what you might have understood, like you mostly start reading about merge sort from top to bottom approach. So, let's say in this example, for example, you have this array, and in the first iteration, basically you divide this big array into two smaller arrays, and then you again divide each of those arrays into smaller arrays. So this is how you divide a big array into smaller pieces, and then you start combining those together, and while you're combining them together, you kind of sort them. So for example, here 860 is smaller than 863, so it will come before 863. So there you go. Similarly, it will just keep on merging until the entire array is sorted. Well, this example is good. It involves recursion and it is very commonly available online. You will find it everywhere. So today what we are going to do, we are going to do a bottom up approach. So I found this syllabus very thorough. I mean, they have really explained it well. So in a bottom up algorithm, first of all, it doesn't involve recursion, it involves iterative approach, and it does the same thing but iteratively. So this is how it goes. You have a width of 1, you start with a width of 1, so that you will only compare the first two elements. Then after that iteration, the width will double itself, so the width will become 2, and then you compare 4 elements, then width will double again 4, and then you just compare 8 elements. So if you look from a from a eagle's eye view, it will look very much similar to what we saw in the previous approach. Instead, the only difference is that instead of going top up, top down, we are going bottom up. So let's code this thing, and then I think we'll have a better understanding of how things are working here. So if you want to visit, I'll attach this link to the video below, so you can just go through it. This is very, very thorough. I mean, they have explained it really well. So let's head back to the IDE and start coding. Hey, if you remember, this is where we left off. We code insertion sort and did some refactoring. And as a part of refactoring, we extracted out this sort interface, which contains sort method and the swap method. Cool. So today we'll do bottom up merge sort. So let's create that class, bottom up merge sort. This will implement the sort interface, and it will get a sort method. Then if you remember, Command Shift T to create a new test case. Then we'll do one more thing. We'll copy the entire test case from here. Before copying, we can make change. We can convert it to sort. Because it implements sort interface, we can do that. And then copy everything here. Then change this part to bottom up merge sort. Everything should be same. We don't have to make any other change in the test. Cool. So currently it fails. Great. Now we have to make it pass. We'll start with the width thing that we discussed. So at first the width will be 1, then it will double itself, become 2, then again double itself, become 4, And this width is basically the first half of the array, the first array basically. And if you double it, let's say if the width is 1, we'll pick 2 elements from the array. If the width is 2, we pick 4 elements from the array. So let's start with that. So our width will be 1 at the first. Then it will go till the length of the array. We don't have this array yet, but we'll create it. Width will double itself, so that is twice. Then we'll have the iterator basically. So let's do that. We'll call it I will be less than the length of the array. I will always be the starting point of the first array. So I will be twice I plus the twice of width. So at first the I will be 0. In the iteration number 2, if width is 1, I will be 0 plus 2 times 1, which is 2. I will be 2, which is the starting point of the second part of the array. So at first we are picking up 2 elements from the array. The second iteration will pick the third and fourth element, then fifth and sixth element, then seventh and eighth element. So in our first iteration of this outer loop with width 1, we'll have, and given the length of the array as 8, the inner loop will run 4 times. Every time it will pick 2 elements from the array. Great. So yeah, let me quickly create this array here. Arrays.copy input and input.length. So the left side of the array will be the ith index. Middle of the array will always be I plus width. And the end will be, middle will always be the width. It's not I plus width. So if width is 1, the left index is 0th index, which is the I. The middle one is the index 1, and the end will be 2. So how to get that 2? I plus 2 times width. Great. Then we have to merge these two array. So start index of array 1, and this array 1 is basically virtual array. We have not actually created an array. We are just maintaining the virtual array based on the indices. So from left to middle is array 1, from middle to end is array 2. Then we'll merge it in the merge function. So you can think of middle as the start index of second array, or the end index of first array, or the length of the first array. So basically this is where the second array starts, and this is the end, or you can say the length of the second array. End is better. So we'll pass array, left, middle, end here. Oh, before creating this method, we also need auxiliary array. And why we need this? We need this because in merge sort you need some temporary space to store the sorted array. So once you are merging these two arrays together, we need a place to store it, the sorted values basically. Then we copy it to the original array. So that's why we need auxiliary array. Now I can create this auxiliary array inside the merge function itself, but then it will create a lot of garbage because in each iteration of the second loop, a new array will be created inside merge function. So it's better that we pass this auxiliary array from the parent function, which is this method. So I'll create this auxiliary array here. This will be same size or length of the original array. And then I'll pass it to this method. Now the merge method have to merge these two arrays, these two virtual arrays, and these are the indices of those two arrays. So I'll again make some quick variable to iterate over the arrays. So the so I will be the starting index of the first array, which is the left one. Int j is the starting index of the second array, which is the middle one, and k is the index for the auxiliary array. This will again start with the left one. Now, if I is less than middle, it means that the first array has some elements to be iterated, or j is less than end. When this condition is satisfied, only then it will run the loop, otherwise it won't. Then if I is less than middle and j is less than end, it means that both the array contains some elements to be iterated. So if the ith index of the array is smaller than the jth index of the array, then I have to copy. So I have to copy in the auxiliary array, and so if ith is smaller, so I'll copy ith, simple. Else I copy jth. So auxiliary array j, and yes, we have to increment the indices as well once we have copied it. Otherwise it will copy the same element again and again, and it will be all hooked up. Else if, now the second part of this equation, else if I has reached the end, and it will reach the end at some point, then we have to copy everything what's left in the second array that is driven by the jth index. So auxiliary k plus plus, so I'll copy everything there in the second array which is driven by jth index. Else if j has reached the end, the same thing, but we'll copy the ith index. Everything which is there in the first array will be copied to the auxiliary array. Great. And once we have done this, we have to copy everything to the original array now. So for that, we can simply run the loop from start, and start here is left till the end and plus plus. So I copy everything from auxiliary array to my original array, and this should merge both the vulture arrays together. And then again loop starts from here. What is this warning? Local left is redundant because, okay, that's why I don't care, this is more readable. Okay, we have to return the array here. Let's see if it works. Okay, what's the error? Spelling mistake. Great. It never works for the first time, I'm telling you. Run again. And come on. Come on. Infinite loop. It is stuck in the infinite loop. Let's see why. Debug, debug, debug. We have width that doubles. We have I that doesn't go beyond the array length. Left is I, width is, middle is width. Always, yes. Okay, I plus width. Because we want to shift this pointer as well. Otherwise it will always start with but here I'm doing that. Let me give it a try. Yep, correct, I was thinking right. So we have to shift this ith index as well with the width. So if we are increasing the width, so we will also increase the middle pointer for the first array. It won't remain the same as the width. So at first it will be 2, then 4, then 8, and it will shift with the ith index every time, because we have different chunks of arrays there. I don't know if I'm making sense, but this ith is basically the starting index of the first array. So we need to add the ith for the iteration to whatever the width we have at that point. So first it will take first two, then it will move the pointer, move the width, move the end pointer for the second array along with the ith index to the second one, and then like this. Yep, let me show you. Two elements at first, then this will come here, this will go there, then this will come here, this will go there. We can do one more optimization here. Instead of copying everything here, I mean copying from auxiliary array to the original array, inside of this loop every time, we can do it all at once outside of this loop. It has the same effect, but we don't have the I. We can get the I from here and make it I equals 0, I is less than array dot length I plus plus, copy everything to the original array, and it should work as usual. So now we have made it more efficient by not copying it on every iteration, but by copying it once the inner part has been completed. That means if the width is 1, all the adjacent arrays have been sorted. So if you don't believe me, then we can print the array here. Yep, that would give a better view of what's happening. So our array is gonna be auxiliary array. Yep, so I'll print the auxiliary array, for which I need arrays dot stream auxiliary array map to object, and then join by comma. So this will print the array. So let's see what we get at the first time. So yeah, in the first iteration, when width is 1, these two will be sorted, these two will be sorted, sorted, sorted. So all the adjacent elements have been sorted. Then in the second iteration, when the width is 2, these 4 are sorted, and then these 4 are sorted. Then when the width is 4, everything is sorted. And this printf statement has come from the test class here, so we can ignore this. So basically it ran, the outer loop only ran 3 times along with the inner loop, inner one. Great, we have done bottom up merge sort as well. We are doing great here, amazing. And this is complaining because it's saying that use array.copyof to copy everything from auxiliary array to our original array. Let's see if we can do that. This is immutable way of doing it. It will create a new memory address. We don't have to do it because that will take more memory. But just to show you that this error will go away if I copy everything from aux array to this in this manner. Provided int, required int. Where did I provide it? Int. Okay, this cool. We can do this way as well, but it will create a new memory space every time. But so we don't need that. So I'll revert it back and let the IDE complain about it. And remember, it does that because immutability is much better when it comes to writing code. Immutable code is good to maintain. You can do parallel processing with immutability safely, and there's a lot of advantages of that. And going forward, we will do some of these stuff, and we'll see how this could help us in, making it faster, performant, and a lot of those things. Cool. So let's take a do. Bye-bye. I hope you will join me for the next video as well, which will be quicksort. And quicksort will do via recursion, and we can do it iteratively as well. So we'll decide at that time. Till then, see you. Bye-bye. Take care.